We're very privileged tonight to have an honest-to-goodness rocket scientist speaking to us. Yes, and I'm going to let Tibor introduce himself, tell you a little about his background, because I didn't print out the bio, and I don't have it in front of me to read, and it's just too much to remember. He's had a very illustrious career, so please welcome Tibor Lak.
Good evening, and thank you for coming out. I know it's hard on Saturday evening. You have probably a lot of other things that you like to do, but I think you're going to enjoy this presentation. Just a little bit about myself. I was born in Hungary right after the war. I came to the U.S., got my education from UCLA, and I started in the aerospace industry right away. I started working there in 1968, December, just when the Apollo 8 flew around the moon. So the way I got started in the aerospace industry is kind of interesting. God has a sort of a sense of humor, because my last name, if you looked at my bio, has the three letters, L-A-K is my last name. It's actually a Hungarian word, probably the shortest one in the dictionary. So the person who hired me was Chinese. He had never seen me until I showed up. And a couple of years later, after I worked for him, he called me in his office and he told me, he says, by the way, did you know that your last name is a Chinese last name? And then his phone rang and he left, and I was sitting there and I thought, the reason he hired me because he thought I was a Chinese engineer. So that's how I got started. I'm so glad that I passed for a Chinese engineer, because I'd probably be driving taxi cabs right now. But I enjoyed my career. I worked a little bit on the Apollo program after Apollo 13 accident. But most of my life I worked on the space shuttle program in the main propulsion area, and had actually 45 years experience there before I retired in 2006, and then I went consulting for a company called Orbital Science, and they're the ones who built we built a launch complex. I was a consultant to them, a launch complex in Virginia, Wallops Island, and it worked. I was so proud that it you never know, you put things on a paper, you do your best, but then when it finally flowed oxygen and other stuff, it was very rewarding. So, and here I am. I'm now fully retired, and so I think I'll be spending the rest of my life here about looking into intelligent design. This is such a fascinating area, and I feel that, is this a surprise that the news, the media is brainwashing us with about evolution? And I see science programs, and I look at and I enjoy the discoveries that they make. All of the discoveries about how big the universe is, and all these amazing pictures that the Hubble telescope, Spitzer, and the Chandra X-ray telescope bring back. It's really opening our eyes how beautiful and how grand the universe is. And then they get into the thing, but then, 4.5 billion years ago, blah, 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 and then it goes into the spin about the evolutionary theory. So what I like to do today is the slide presentation I put together is aimed at looking at the evidence for intelligent design in the universe. And that will be the first part, and then we'll take about a 10-minute break, and then I'll go into the second part, which is looking at God's attributes in light of the infinite universe that we have. And I also find it interesting that in the beginning of the scientific revolution in the 1700s, the scientists back then were all believers in God. There's no question in their mind that God was the creator of everything. So they looked at the universe and everything around them as evidence of God's ingenious creation. And as a result, their purpose was to understand the designer, God. And as a result, they came up with formulas, and equations, because they felt that the world that God had created was intelligent, it had a purpose, and it could be understood. It was designed for us to understand. On the other hand, in the Eastern culture, in China, Japan, that advancement wasn't made there because their worldview of the universe was very chaotic. They believed in demons and angels that were constantly fighting each other. So because of this worldview of being chaotic, they didn't really bother to really study it, and because they thought it was all didn't make sense. It was very confusing and chaotic. So what is interesting is that as I see now where we're heading, we're in a way are going back to looking at the universe and everything as having no real purpose, all random. It's all about explosions and lucky chances and coincidences. But I hope that if the slide presentation does what it's supposed to do, you'll be able to see the incredible design that God has prepared for us to enjoy in the universe. So with that, the first part of it, as I said, we're going to talk about the wisdom of God. In Jeremiah it says, God had made the earth, and by his power he had established the world by his wisdom and stretched out the heavens by his understanding. So it's clear that the Bible claims that this is not a matter of accidental circumstances. The second part will be to look at the invisible attributes of God. So for the invisible things of God, of him from the creation of the world, are clearly seen, being understood by the things that are made. His eternal power and Godhead. So we're going to look at God's attributes, his attribute of knowledge, power, wisdom, mercy, grace. And then if we have time and if you're still interested, we can have a question and answer period. And I set it up so that Esther will answer, my wife, by the way, my wife is here. She'll answer the hardest questions and we'll go from there. Actually, she's becoming my understudy. Whenever I do my slides, go through that, I ask her, what do you think? Does it work? And she'll say, no, it doesn't make sense here, so change it. So this has been approved by my wife. So I thought the best way to get started would be to look at our universe, our solar system, as a big, giant spaceship. Because that's what it is. We are traveling through space. So if we look at what does it take to live in space, it's not been that long, maybe the last 50 years or so that maybe 60, 70, in my lifetime is when men actually went into space and are living in space. Now we have humans living in space 24/7, excuse me. And it took a while for us to figure out what do we have to have up there to protect human life. So I think this is a good place to start to see what we know about what it takes to protect life in space, and then compare that, well, what does it look like on the Earth? Because we have the same thing. We're traveling through space. Space is a very hostile environment of very dangerous radiation, vacuum, hot and cold extremes. So I made a list of things that I thought, well, these are things that you have to have. You have to have a power source. And we'll talk about that. What does it look like for the Earth? We have to have a way of controlling the temperature in space in this very harsh environment. And the space station has radiators and heaters to keep the crew comfortable and at a temperature where they can survive. Then we have to have a way of shielding our space station, our spaceship from radiation, micrometeorites. We have to have a way of converting the energy from a raw source to a usable source. So we have solar cells here, which are what play that role. They takes the sun's energy and they converts it into electrical energy on the space station. And then we have to have systems that provide breathable atmosphere. Now, actually, right now, the space station depends on the ground to launch oxygen and nitrogen, and they replenish these usable, these expendable gases because eventually they leak out. So they're not self-sufficient yet, but this is something that we must have in our spaceship. And then the other thing is very important is to maintain the attitude of the space station. If it wasn't always pointing to the sun, it was rotating, which is very easy to get a rotation in space, it could lose its connection to the sun and also could destroy itself. So these are kind of the top level items that I wanted to show. Well, what does it look like on the Earth? How did God solve this problem on the Earth? Well, starting with the power source, of course, this is our power source, is a nuclear reactor 93 million miles from here. And our sun is designed to provide constant power. Now that is so important because if the power output of the sun would vary a little bit, it would either get very hot and it'd be over for us, or if it was not enough, we would be freezing and that would be over for us also. The fact that the sun is able to put out a constant energy is critical to life on Earth. Interesting thing is that of course, the sun's energy is generated by thermonuclear reaction. Hydrogen atoms are fused into helium atom in the core of the sun, and it's about 28 million degrees inside the sun. But on the surface, as this energy comes up and it gets absorbed and re-irradiated, at the surface it's 11,000 degrees. Now what's important about that is it's very important because the sun actually radiates its peak energy at the visible spectrum. If it was infrared, it wouldn't be good for us. Or if it was at the higher frequencies, it wouldn't be good for us. But it radiates right at the visible spectrum, which is what plants need to process photosynthesis. And we'll talk about that a little bit later. And also because the sun is a big nuclear reactor, it emits a lot of harmful radiation that is deadly to life. So it's nice that we have this constant energy source, but it's also very dangerous for life here, unless we have a means of protecting us from that deadly radiation. This is just a illustration to show the various types of stars that we have discovered. Over here is the sun. I hope you can see that. And then we're going up to larger red giants, Arcturus. Now we go to even larger. Arcturus is a very small one on the bottom, the third from the left. But the largest red giant that we've seen is Antares, which is so large that the entire inner solar system up to the orbit of Mars would fit in very nicely inside the interior. So we're looking at very large stars. And the reason I mentioned Antares because I'm going to talk about later on about supernova, and just keep in mind that this is the type of star that I'm going to use as an illustration on a supernova process. So this is a picture of our solar system from Mercury, Venus, Earth, Mars, and the asteroid belt. This is a dwarf planet, Ceres, there. These are all called the rocky planets because they're composed mostly of rock and heavy metals. And then after the asteroid belt, we have the gas giants, Jupiter, Saturn, Uranus, Neptune. And we're about 93 million miles from the sun. It takes light about 8 minutes to reach us from the surface of the sun. So it's quite a distance. We are discovering exoplanets, planets outside of our solar system. They have been over 1,000 planets already discovered, but most of these planets are Jupiter-type planets, very large gaseous giants. They have found some Earth-like planets, but what's unique about these is that their orbits are highly eccentric. In other words, they come in and out of they're very elliptical. And so their temperature changes drastically as they come in and out of the orbit around their sun. So what is unique about our solar system and our planets, that these planets are almost nearly circular. They're changing from the closest approach to the farthest approach is not that much. So how did these planets form? And what I've tried to do here is, there's a lot of really good animation on the media that shows how things form. But really, it's almost like a Hollywood production. The science behind it is lacking, but it's presented so well that it almost appears as though, hey, there's no question about this. Look at that. It makes sense. I can see it. This picture, look at first. Actually, there was a picture on one of the Chandra website that showed a picture like this, and it was embedded in the pictures of photographs. And first I thought, why, did they really take a picture like that? And as I read a little bit closer, it was an illustration, but it looks so good and so realistic. So anyway, this is the current theory of how the inner planets were formed. The theory says that the heavy elements didn't come from the sun, but it came from outside of the sun. The theory is that there was a star, a red giant, that went supernova. It collapsed on itself, blew up, and in this explosion generated the very heavy elements above hydrogen and helium. And this cloud of gas and solids passed through our solar system, and the sun's gravity captured it. It brought it into its orbit, and then eventually the particles formed, collided each other, and formed the planets. Over time, these little clumps became planetoids, and then they estimate there were thousands of these planetoids, but as a result of time colliding within each other, those hundreds and thousands of planetoids became the 4 rocky planets that we see today. So what's wrong with this picture? Well, this picture is actually, there's nothing wrong with this picture. This is good. This is actually a photograph of taken by the Chandra X-ray telescope of a supernova. This is it shows the internal collapse of the original star and the explosion of the gas clouds that is emitted as a result of that. This particular supernova, the diameter of this gas cloud is about 10 light years across, so it's very large. It is located about 11,000 light years from Earth. So it's a distant supernova. So the theory assumes that in this gas cloud, all the heavy elements up to uranium were formed, because we find this on Earth. We have all of the heavy elements all the way up to uranium. So they had to have been formed somewhere. So they assume that this all came from this exploding gas cloud. Now, so far, when they looked at this spectroscope, they only found phosphorus, which is kind of low in the periodic table of elements. It's well below iron. But they haven't found anything anywhere close to uranium, which has an atomic number of 92. And of course, the higher the atomic number, the more energy it takes to form and fuse the atoms into these heavier elements. So far, there's really no evidence that we actually have seen these heavy elements formed in a supernova. So being an engineer, my background, I did analysis. I loved to crunch numbers. Even today, I crunch numbers. So I thought, well, let's see what if it makes sense. So here's a illustration of a supernova of an expanding cloud, and I made some assumptions. So if I assume that a large red giant like the Antares that has the inner diameter so large that the solar system could fit in it, the inner solar system, if that exploded, what would happen? And I also assumed that this star was very close to the Earth, like 4/10 of a light year to the Earth. Now, to put that in perspective, the closest star to us right now is over 4 light years from us. So this supernova had to be 10 times closer than the current star is to the Earth. And then the other assumption I made was that as this expanding cloud, it has to pass through the orbital plane all the way up to Jupiter, because Anything that goes the other way doesn't get captured by the sun. Only the thing that passes through this little circle. So how much mass is actually captured by that, going all the way out to the orbit of Jupiter? Well, it turns out that a very small percentage of this very large star that exploded, and of course it assumes that all of that mass was converted to these heavy elements, and actually the remnant star completely disappeared. So it's kind of conservative assumption. So what it showed, and this is a simple analysis, it shows that the amount of mass that came from this exploding supernova was only about 5% of the mass of the inner rocky planet. So it was not even close to what we need. We have to be that supernova has to be extremely close to the sun. I mean, it almost has to be a binary star for it to release enough mass to account for the inner solar system. What this also means is that as we're finding rocky planets, this theory would say that every place you find a rocky planet outside of our solar system, it had to be caused by a supernova. So if we find these supposedly thousands of solar systems that have rocky planets, it means that right next to it, there had to be a supernova, which kind of makes it a little bit difficult to comprehend or understand. So one thing is that right now, my opinion and my conclusion is that the supernova doesn't adequately explain the formation of the inner planets. How these inner planets were formed, I don't know, but this theory it needs to be revisited again. Another thing that is interesting is that this particular picture shows the distance of the planets from the sun. You have Mercury, Venus, Earth, Mars, the asteroid belt, Jupiter, and Saturn. You can see the planet distances are expressed in terms of astronomical units, which means that the unit is the distance that Earth has from the sun. So Venus is about 0.7 times the distance of the Earth from the sun, etc. So why is that interesting? There's an equation that was discovered by Titius Bode in the 1770s. They looked at the planets and they looked at the distances, and they came up with a relationship that's is named after them, and it showed that there is a certain predictable distance from the planets. When you go from Venus to Earth to Mars, you can predict where these planet orbital distances should be. They were not random. As the theory of the gas clouds and the solid matter forming, it should be random. There shouldn't be any particular order. But the data actually shows that there are very ordered distances from the sun. These are this table, if you can see it well, shows the closest and furthest approach of each of the planet, and then what this equation predicted. And it's very close. It's right within the middle of it. That's what that red line shows. As a result of this equation and this model, the asteroid belt at the time wasn't known yet. They didn't know there was an asteroid belt because they couldn't see it with their telescope. They also didn't see Uranus. But this equation predicted that there's something there, and they went and looked for it, and lo and behold, there was a planet there. So this kind of proved their theory. It wasn't just going after the fact, but actually predicted that. Okay, so we all know that the closest we are to the sun, the hotter it is. And of course, the further we move away from the sun, the colder it gets, because the energy from the sun is diminished. But here's a plot that shows the distance of the planets from the sun in terms of millions of miles. So you have Mercury, Earth, Mars. I left Venus out because Venus actually has a greenhouse effect, and it's a runaway planet, so it's a little bit higher off from this curve. But all the others kind of fit nicely. So as you go out towards after Mars, it starts to get really cold. Now, if you superimpose on this temperature, on the left-hand side is a temperature in Fahrenheit from minus 400 degrees to plus 400 degrees. If you superimpose the temperature where liquid stays in the liquid form, you'll see that this intersects this line, this temperature line from the sun. And what it says is that the liquid phase can only exist in a very narrow band from the sun. It's not everywhere. It's a very narrow band. We call it, actually, scientists coined the name Goldilocks zone because it's not too hot, not too cold, as you know the story. So the amazing thing is that if we were just a little bit further away from the sun, then water would freeze and life would be over. If it was a little bit closer to the sun, then we would have steam, hot steam, and again, we couldn't support life. So we are just at the right distance from the sun to support life. So this again is, if the orbit of the Earth was more elliptical than it is, again, we would be going in and out of this hot and cold zone, and again, it would be over. So to me, again, this shows a divine design that we happen to put it in quotes, we happen to be just at the right distance from the sun to support life. The other thing that we needed in the beginning of the charts was temperature control of the Earth. As you know, on the surface of the moon, the temperature varies from plus 200 degrees Fahrenheit, where lead melts, and in the shade it goes down to minus 260 degrees, where it's extremely cold, because there's no atmosphere, but that's what would be there on the surface of the moon. Now, on the Earth, we have an average temperature of about 70 degrees plus or minus 40, 50 degrees, but it's a lot narrower and it's a lot more controlled. And why is that? That is because we have a large ocean that actually is the reservoir for absorbing and evaporating heat. And the large oceans, the spin of the Earth, and these large oceans regulates the temperature of the Earth on the surface, so we have a nice habitable zone. Our atmosphere contains just the right amount of carbon dioxide. Now, why that is important is because as the Earth rotates from day to night, at night it radiates and loses heat to deep space. If we didn't have carbon dioxide in the atmosphere, the temperature of the Earth would cool down on the night side. But because of the presence of carbon dioxide, it slows down the rate of heat loss so that it doesn't get as cold. And of course, if we had too much carbon dioxide, then it would get hot because it would trap the heat during the day. So we have, again, this really nice fine balance of just the right amount of carbon dioxide to control the temperature of the Earth. The other thing about the carbon dioxide is that in addition to trapping heat in the atmosphere, if we had much more carbon dioxide, and right now I think concentration is on the order on the tenths of % of carbon dioxide. But if we had much more, it would actually filter out the light from the distant stars and galaxies, and we wouldn't be able to see the universe as well as we can. So again, God did this fine-tuning of just the right amount of temperature, and so we can also enjoy the beauty of the universe. Water. And Jim, I think about you every time I look at this slide, because Jim told me that one of his early projects was about looking at the properties of water, liquid water. Water is, I call it a designer fluid, a designer liquid. Now, I think what happens to us over time is that we are so used to things that are so common that we lose the awe of that particular liquid. What's so big deal about water? Nobody gets excited about water unless you're thirsty. But on this chart, you can see that the heat capacity, the ability of liquids to absorb and release heat, is extremely small compared to what the water has. The orange bar is what water has. All these others are different types of liquids. And this is important because if water didn't have the properties to absorb heat, then during the daytime, during the summer season, there would be a lot more fog in the air, and it would really affect our temperature on the Earth. But the one that I really like is the fact that water is the only liquid that its solid phase, right at the freezing point, is lighter than the liquid. If you plotted the temperature and the density of these different liquids, you would find that all of them drop down. Water, it levels off and then comes down. So why is that important? Because if ice at the freezing point wasn't lighter than water, then as the water started to cool down, it would sink to the bottom, and the lakes and rivers would freeze up from the bottom every winter, and the animals and fish and plants would die. But because it forms at the surface, it actually acts as an insulator to protect the rest of the water from getting too cold. So it's amazing. This is the only liquid that has this property, that it's lighter than the liquid phase. Water is also a universal solvent, which means that everything dissolves in water. And this is important for plants and animals because all these minerals are processed by water and absorbed by the plants in their capillary things. The water also has the high surface tension, which means that water can rise in a capillary tube very high, so it enables trees to grow very tall. If it didn't, then we wouldn't have sequoias and very tall trees. The other interesting thing is that when you look at the gases in the atmosphere, you have oxygen, nitrogen. Those are the two. Nitrogen is about 78% of the atmosphere. Oxygen is about 20%. But these two gases and water vapor, because water vapor is lighter than either oxygen or nitrogen, when it changes phase, when it evaporates, it rises above the oxygen and nitrogen. And as it rises, it cools, condenses, and the winds carry it, and we have precipitation. If water had the property of being denser than nitrogen or oxygen, we would just have fog, and there would be no rain and no way to water the continents. So again, this is a basis of the water cycle. If you look at this picture, which one sticks out? Well, which one has the water? Only Earth has an abundance of water. You look at Mercury and Venus have absolutely almost no water at all. Mars has no water. They think Mars may have had water, but it definitely doesn't have any water there. But there's no reason, if you look at the comparison between Venus and Earth, they're about the same size, they have the same density, they're in a similar location to the sun. It's not one is really far out and the other one's in. But only Earth has this abundance of water. 75% of the surface is covered with water. So there's really no good explanation where all this water came. There are theories that says that all this water was brought in by icy comets. But the question is that how come only the Earth got all this water and not the others, not Venus? How come they don't have it? And the other thing is that why did it stop at this level? It could have just continued, and we would be, talking with scuba gear right now. Okay, this is something that I never hear on the science channels that they bring up the nitrogen factor. Again, because it's so common, we take it for granted. But again, just like water, you look at the nitrogen or an atmosphere. Mercury has nothing, 0. Venus has about 3%. Mars has about 3% nitrogen in its atmosphere. Earth has 78%. Again, there's this huge discrepancy between the Earth and the other planets. So, as I said, nitrogen gas is inert, which means it doesn't react with anything else, and it has very similar properties to oxygen. They're right next to each other on the periodic table. And because they're similar densities, they diffuse well into each other, which is very important. Why do we need large quantities of nitrogen? Because in our oxygen-rich atmosphere, because we have oxygen here produced by plants, If we didn't have nitrogen to dilute it, everything would burn. There would be no way to have life on Earth. So we need this nitrogen to dilute the oxygen so it doesn't become combustible. If we had a gas, another inert gas like helium, which is much lighter, then that wouldn't work either, because it would work as an inert gas, but the problem would be that this lightweight gas, helium, and some of the other inert gases are lighter. They would rise to the out of the atmosphere, and yet still you would have an oxygen-rich atmosphere closer to the ground. So without all this nitrogen, which is, again, we don't know where it came from, how it's produced. It's not produced by inside the Earth. It's not something that bubbles up out of the magma. It's just there. But where did it come from, and how come we have so much is a mystery. Nitrogen is also essential to a building block of life. All organisms require nitrogen to live and grow. And I'll touch on the nitrogen cycle a little bit, because it's amazing what God created there. So again, there's no real explanation where all this nitrogen came from, and I haven't heard anyone really discuss it. It's just something that it's too complicated, I guess. So now we talk about the protection from the sun. As you know, mentioned that the sun radiates deadly radiation towards the Earth that's deadly to life. What we have inside the Earth is we have a molten core that swirls and generates a very strong magnetic field. I hope you can see it. I don't know if my pointer will point, but right there in that blue area on the right-hand side, right in the middle is a white dot. That's the Earth. So that's the magnetic field that the Earth produces. And this picture illustrates that the charged particles coming from the sun are deflected because of this very strong magnetic field. If it wasn't there, if this magnetic field would not be there to protect us, there would be no life on Earth. This magnetic field is generated by a swirling motion inside the Earth. No one knows how it got started. There are no explanations for that, but it's there, and it's the swirling motion. It's like a giant dynamo that produces these enormously large magnetic fields. Now, the thing that's interesting about this, the reason we can stay on the space station is because we're inside this magnetic field. We're only about 300 miles from the surface of the Earth, and this thing extends into tens of thousands of miles into space. Once we leave this magnetic field, we're in danger. So the trip to Mars, if it ever happens in the future, those astronauts are really risking their life, because there is no protection against the deadly radiation from the sun. Again, Earth is unique in this sense that it's the only one that has this very strong magnetic field. Mercury, Venus, Mars have no magnetic fields or extremely weak magnetic fields. So again, Earth stands out as unique in the inner planets. The other thing we have is we have radiation and ultraviolet radiation that comes from the sun. The particles, the high energy photons, are filtered out by the atmospheres, and meteorites burn up the small ones in the atmosphere. That's a level of protection. The ultraviolet radiation is deadly to plants and life. We're finding out, as the ozone layer is opening up over the Antarctic, that people in New Zealand are getting severe burns from ultraviolet radiation, getting cancers from that. So if we didn't have this ozone layer to protect us, again, there would be no plant life, no animal life. The ozone layer is made up of oxygen molecules, 3 atoms of oxygen, and it works so effectively that it filters out about 98% of the incoming ultraviolet radiation. Now, the interesting thing here is that oxygen is only produced by plants. There's no natural means of producing oxygen on the Earth. Nothing comes out. It's so reactive. Only plants can produce it. And yet, we have to have oxygen in the atmosphere before to protect the plants that are going to be producing oxygen later on. Okay, now we go to solar cell, power generation. How is the power converted? We have the sun that puts out a lot of energy, but it's useless unless you have a way of converting it to useful energy. So this is a picture of the space station, the solar panels, and the way it works is sunlight hits the solar panels and it creates electrical current, and they use electrical power on the space station. The equivalent, what we have on the Earth, these are the equivalent solar cells. They look a lot different, but they're a lot more efficient. So the plants, the leaves, are the ones who convert the energy, raw energy of the sun, and convert it into chemical energy in terms of foods. So this is a picture of a leaf, a simple leaf, and if you look at it closely, it's extremely complicated. You have the chloroplasts trap the light, the water comes up from the plant, combines with the carbon dioxide that enters the leaf, it produces sugars and exits oxygen. So in this one little leaf, we have not only energy conversion, but we're able to absorb carbon dioxide from the atmosphere to regulate the carbon dioxide content of the air. And we also produce oxygen for animal life. And it's actually it's a lot more better than the solar cells on the space station, because once the solar cells in the space station are damaged, it's over. Plants, as we know, repair themselves. They actually shed the leaf and regenerate themselves annually. So this is the byproduct of photosynthesis. All this food that is there, it's actually very tasty and good for us. It contains minerals and vitamins that we need. And in addition to that, we get oxygen and absorb carbon dioxide. So the question is this process is so complicated that even the best scientists can't reproduce this yet in the laboratory. So how could this process develop on its own? This is another favorite one of mine is the nitrogen cycle. It's maybe hard to see the picture, but basically what happens in the nitrogen cycle is all living things need nitrogen, but the nitrogen in the air is not usable directly by plants and animals. It has to be converted from a non-reactive nitrogen to something that's reactive, the nitrates. And what does that are all these nitrogen-fixing bacteria is there in the soil and in plants that convert this. And there are different stages, so it's kind of amazing that you have some bacteria, nitrogen-fixing bacteria, that take the nitrogen gas and breaks it down into ammonium, and then another one takes that and converts it into a nitrate, and then another one converts it into nitrite before the plants absorb it. You have another set of bacteria that is used to decompose animal tissue and plant tissue and waste, and again creates ammonium for later processed by other bacteria. So these things are so well balanced, and of course at the very end on this loop on the right hand side, there's another set of bacteria that take the remainder of the ammonium and the nitrates and they convert it back into gaseous nitrogen, so that the atmosphere is not depleted by the plants and it gets absorbed in the soil, but it keeps being recycled. Again, it's just to me it's amazing. Okay, and there's more. We're going to take a break in about 10 minutes, and then we'll go to the next phase. But as I was putting this together, the photosynthesis, the nitrogen cycle, and I thought, well, there's more to that than just photosynthesis and nitrogen. We need to have things like miniature flying robots that pollinate the plants to do that. I mean, you can't just not have that. And we're finding out that as the bee population is dying out, that we're getting into trouble on the agriculture, how the plants are going to be pollinated. So God created the miniature robots, insects and birds, to pollinate the flowers. And these, when you look at these are by themselves are amazing flying machines. How they fly, the different types of vision they have. the different type of navigation system they have, how they navigate and communicate. I mean, this is just the whole world that is part of what seems like a simple bee. And then, of course, you have another level of predators that keep these insects in balance so that they themselves don't overpopulate and destroy themselves by overpopulation. We have birds that protect trees, woodpeckers that eat insects. And then on the underground, there's a whole world of insect, worms, and what have you, that cultivate the soil underground. So it's extremely complex, much more complex than we first think. You have trees that hibernate during the winter, lose their leaves, and then come back in the spring. And so it means that these trees have some kind of a built-in temperature sensor, because as soon as it starts getting cold, the trees start producing fluid. They start losing their leaves, and when it starts to warm up, they turn on the machine and they create leaves. I put this chart together a while ago, and I thought it would be interesting to see this again because we're talking about insects. Although monarch butterflies are basically just beautiful, but what's amazing about them is these monarch butterflies are really an amazing species. They fly from Mexico, from central Mexico, and they fly about 3,000 miles to reach North America, where they live. And so you have the first set of parents that fly, they lay the eggs, they die, and then their offspring, the children, they live, they lay their eggs, they die, and then the grandchildren grow, live, die, and the grandchildren lay their eggs. Now the thing is that the fourth generation, by the way, these children and grandchildren only live to be about 5 weeks. But the great-grandchildren, they live to be 8 months old. So when they are hatched, they're a lot bigger because they're going to have to fly back down to Mexico. So they make the 3,000-mile journey from North America back to the same place in Central America. Now, the amazing thing is that how do they find this location? They go back to the same little spot in Mexico. There's no navigation, there's no maps or GPS or anything. And the thing that's amazing is that they have never been there before. Their ancestors, their parents, grandparents have all died off. So they're the first ones to make it. So where in the world in that little pea brain is all this information there? And okay, amazing. So you have the same thing we talked about photosynthesis, and now you have the same thing in the oceans. You have planktons and plants that convert the sun's energy into oxygen, absorb carbon dioxide. But these things are a lot different than the photosynthesis on the Earth. So it's not that the planktons migrated on the ground and became trees and plants, or vice versa, but they're completely different, but they're very sophisticated. So we need actually both of them. If we only had planktons in the ocean, we wouldn't have any life on the Earth, on the ground, because there's no way to produce enough oxygen. Or if we just had plants, there wouldn't be enough oxygen in the oceans. So both of them are important. This is our, like I said, we have to have a way to stabilize the gyroscope on the Earth, as a space station has a constant attitude control. Our stabilizing gyroscope is the moon. It's 240,000 miles away, and it keeps the axis of the Earth from wobbling. Earth is the only rocky planet that has a large lucky moon. None of the other, Mercury doesn't have a moon, Venus doesn't have a moon, Mars has 2 small asteroids, but they're very small. It's now been discovered that without the moon, the Earth's axis would wobble and there would be no life on Earth. So they're now discovering that having this large moon is not only just nice, romantic in the evening, but it's critical for life on Earth. Okay, so the theory of the origin of the moon. Again, these pictures, I showed this to my wife and I said, Look at that picture. That almost looks like a photograph. I mean, so real, right? So this is the theory of how the moon was formed. The theory is that there was a Mars-sized planetoid, long-distance pass that hit the Earth, and it splattered all this material into orbit, and then this material condensed and coalesced into to the moon that we see today. At a later time, now we have the moon, but at a later time, another small planetoid came by, and this time, instead of hitting the Earth in the middle and splattering it, it just kind of nicely, gently just spun it to the side. So, and then it tilted the angle by 24 degrees, so just right. So, so I mean, you know, if you have a video of it and you show it, it looks real, right? But there's holes in it. Where's this small planetoid? And things in orbit don't just glance each other. They smash, and things break into smithereens. So. Oh, and it also caused the Earth to spin at 24 hours, which is what we have right now. Not too fast, not too slow. Here's, to me, this is amazing. You know, if you look at the moon, that it's just the right size to cover the sun so that we have a total solar eclipse. We can see the corona of the sun. And by the way, this is how they discovered helium gas. They looked at the electrospectrum from during a solar total eclipse, and they discovered the gas, and that's why it's called helium, coming from the word helios, or sun. But without this, it would have been taken longer to discover helium. So it turns out that the only place you can see a total eclipse is from the Earth, because the other planets don't have large enough moons, or their distance is not the right distance. So here's the thing. Here's the thing that's difficult. You have, in this picture, you have on the bottom picture, you have the sun, and that's just an illustration. These are not the right dimensions. The picture above it is the right dimension. You have that enormously large diameter sun, and there you have a little pea-sized Earth on the bottom. But the thing is that the sun has a certain diameter, the moon has to be a certain distance from the sun, and it has to have just the right diameter and has to be just the right distance from the Earth for this total eclipse to occur. So this person gave me this calculation. He said he calculated the probability of this all coming together to have a total solar eclipse, and he came up with a number 10 to the 34th power. I don't know what that number is, but I mean, you can look at it that the likelihood of something like this coming together on its own is extremely rare. So evolution has no explanation for this amazing coincidence, but you know, as you look at the creation that God has put together, we see that this is the hand of a super intelligent creator. We're finding out that these other planets, the gas giants, serve a purpose. In this particular sequence, the 1994 comet approached the Jupiter, and it broke up and it got absorbed by Jupiter. So they realized that Jupiter and these gas giants are actually acting like big giant magnets that absorb these incoming comets to protect Earth. So even today, I was listening to a program that said, about Jupiter, and this is the quote from Professor Lawrence Krauss, who's an astrophysicist. He said, without Jupiter, there would be no life here. Okay, so now we left our solar system, and this is our Milky Way quickly. Our Milky Way has about 200 billion suns. Of course, this is not a selfie of our Milky Way, because we can't take it, but the diameter of the Milky Way is about 100,000 light years across. In the center is a big giant black hole that has several million times the mass of our sun. We're located between spiral arms, and we're flying around the center of the Milky Way at a speed of 540,000 miles an hour. And we are actually, I used to think, why aren't we in the center? Aren't we important enough to be in the center of the Milky Way galaxy? Well, it's a good thing we're not there, because if we were there in the center, the radiation from the nearby stars would be deadly. We again we have to be living in the suburbs in order to survive. And also, if we were in the center, the light from the surrounding suns would block out the view of the universe. So God put us right at the right spot for us to have the best view of the universe. This is just a recent discovery. Voyager 1 and 2 left our solar system, and as it was leaving, I think this happened a couple of years ago, they discovered this enormous magnetic cloud at this end of the heliosphere. These blue and red squirrels there represent the sun's magnetic field. As the sun's magnetic field is rotating, it generates this enormous envelope that envelopes the solar system. Now, as they were going through here, they found these bubbles of what they called magnetic bubbles there. And of course, these magnetic bubbles are like 100 million miles across. They're about the same distance as the distance from the Earth to the sun. And they are discovering that these magnetic bubbles are there to absorb the incoming radiation from nearby stars. So it's another level of protection to protect life from life on our solar system. So this is how it would work. You have these deadly cosmic rays coming from the other stars and are being diverted away from the solar system. So if you look at this, and I kind of like this, I said, well, this is really our spaceship. Here's our spaceship. In the center of it is our Earth is our crew compartment where we live, and the rest of it is there to protect and guide us through the universe. Theory of evolution. I laugh and I'm frustrated because a lot of times they'll talk about a process and they'll say, this is how it happened, and then they get to a certain point where they say, well, there was a miracle that happened. So this particular cartoon shows this scientist developing a very complex formula, but then he gets stuck, and then he says, well, then a miracle occurs, and then he comes on. And so the professor is telling him, you need to be a little bit more explicit here. You can't just expect a miracle to occur. But these are the terminologies that are being used in the media. Miracle planet, lucky moon, chance collision. And these are things I just jotted down because I thought it was very interesting. Astonishing cosmic coincidence. These are not scientific terms. If you have a scientific theory that depends on these terms, you need to review your thing. So in summary of the intelligent design, Earth is just at the right distance from the sun. Earth's strong magnetic field and the ozone layer protects us against sun's deadly radiation. We have this very lucky moon that stabilizes the Earth, critical for life. Total eclipse can only be seen from the Earth, and the odds of this coming together are astronomical. The abundance of water to maintain the constant temperature. We have nitrogen, abundance of nitrogen. We don't know where it came from, and allows for an oxygen-rich atmosphere. Nitrogen cycle converts nitrogen gas to usable nitrogen. Photosynthesis to not only produce foods, but absorb carbon dioxide, produce oxygen for sea and land animals. The gas giants protect us from the incoming asteroids and comets. And the planetary distances are not random, but are orderly and predictable. And the sun's magnetic field protects the Earth from the nearby stars. And we're located in a part of the galaxy where the star concentrations are low. And I have another one later on in the second part that I think is an even stronger evidence that the universe didn't come about by random chance. So before the break, is there another Earth in the universe? We're looking at. It's interesting that about several years ago, in my lifetime, when I was still in high school. As a matter of fact, in junior high school, I did a project on Mars, science report, and I had pictures of showing the canals on Mars and vegetation and the change of seasons. So at that time, we were really expecting to see Martians living on Mars. But since then, since we landed there, our best hope is now is to look for past evidence of life on Mars. So they know that there's no life on Mars. So is there another alien Earth? I know a lot of you know Dr. Hugh Ross. He's a well-renowned astrophysicist. He identified 300 parameters that are needed to have another Earth. This is in his April 2004 publication. He came up with that for this 322 factors to come together, the chance is 10 to the 282nd power. Now, I don't know if that's 282nd or whatever, but it's big. It's a huge number. I said that it takes the chances that high for another Earth to occur without divine intervention. Just as a comparison, if you're playing the lottery, your chance is about 1 in about 200 million. So the chance of finding another Earth is extremely small compared to winning the lottery. It's interesting that scientists, and I watched how the universe works, the birth of the Earth. You can see it still. I think it's still on the Science Channel. They acknowledge that the probability of the Earth coming into existence by chance is very remote. And these are the quotes that they have. For the Earth to be here, we had to beat astronomical odds. We were lucky. These are their terms. Astronomical odds. We're lucky. Somehow our solar system hit the jackpot. So I thought, in tongue-in-cheek, I said, if anyone believes in that all this came together by chance, you know the line from the what is that movie, the Hunger Games? It says, "May the odds be ever in your favor." So, if you'd like to take a 10-minute break or 5 minutes break, we'll come back and finish the second part. So let's continue. We just finished our survey of the solar system, and now we're going out of the solar system and going into the universe. So the second part is not so much about intelligent design, but about the vastness of the universe. And as the Bible says, the heavens declare the glory of God. I believe that this is where we can look at the universe and draw some parallels, some conclusions of the nature of God, who He is. And so we'll quickly go through the universe. We're going to go at lightning speed, even faster than the speed of light. So this is actually the picture of Andromeda Galaxy, which is 2.5 million light years from us. And then here is our companion. It's a smaller galaxy, about 3 million light years from us. It turns out that our galaxy is flying at 1.3 million miles per hour. So since you left your home this evening, you covered a few million miles, and you didn't even break a sweat. So I hope this picture comes out well. This is a picture of the Hubble Ultra Deep Field View. They looked at a portion of the sky where they couldn't see anything from the ground. This is a patch. If you made a 1 millimeter by 1 millimeter square, this is something like this, even smaller, and you held it out at arm length. So you're looking at a piece of the skies that big. This is what you would see. There's about 10,000 galaxies in this picture. And you can see some of them are red, some of them are white. So the reddish galaxies, they believe, are galaxies that are moving away from us. It has a Doppler effect. So our galaxy is one of 100 billion galaxies that we can see in the visible universe. And they estimate that the visible universe is about 13.7 light years. But that's as far as we can see. Now, it's interesting, I saw some recent discoveries that talks about inflation, that they feel that when the universe expanded very rapidly, that it expanded so fast that actually the universe is, what we can see, is much, much bigger than the 14 billion light years that we can see. Some of the lower estimates are on the order of 40 to 50 billion light years, but some of the larger estimates are so big that it's hard to comprehend. So the bigger estimate is that if you can visualize this larger maximum universe, if you started reducing it, shrinking it down, and you got to a diameter that is about 14 billion light years, then our universe, which is 14 billion light years, in this contraction would be the size of an atom. So that's how much larger the real everything out there is compared to our universe. So besides galaxies, what we can see recently, they discovered that there are things there that we can't see, things that dark energy and dark matter. And these actually are larger, they're more than the part of the universe we can see. We can only see about 5% of the visible energy. The 95% of the universe is invisible to us. We can see its effect. We can see the effect of gravitational distortion as the light from distant galaxies passes through the dark matter, and we can see the acceleration of our galaxies out in the distant limits of universe being accelerated, but we can't see those yet. So I find this amazing. I'm going to just mention my view, and I think it's so appropriate, when we look at the universe and we look at the vastness of the universe, and it is, I really think it's a picture of God's vastness. And as we discover great new things, I think it's appropriate that we discover new things about God, who He is, the dark matter, the dark energy. I also thought, I love symbolism, and I kind of, when I thought about this, I think isn't this interesting that here we have a kind of a trinity. We have a part that we see and parts that we don't see. So if you're a symbolic person like me and like to make analogies, I say, isn't that interesting that here we have the visible part is God manifesting Himself to man, and then you have the Father and the Holy Spirit. So this is totally out of science, but I thought I'd share it with you. Okay, so this is why I asked you to come closer to this screen, because this picture is actually a computer-generated picture of the galaxies and filaments and galaxy clusters. So if you see, if you can see well enough, those blue dots that you see on this particular map are super clusters of galaxies representing on the order of 10,000 galaxies. And then you have these filaments which represent about 1 million galaxies. And then there's more. This is even a larger picture. So the little insert was the picture you saw before, and then this is just, again, just an enormous number of galaxies and in the universe, all connected. It looks like a fine embroidery. So this is only a portion of the visible universe. It's interesting, I find it interesting that the Bible correctly predicted the size of the universe, because when you look at the number of galaxies, the hundreds of billions of galaxies, and the hundreds of billions of stars in the galaxies, you come up with a number that is so vast that actually there are more stars in the universe than there are grains of sand in all the beaches of the world, not just Huntington Beach. If you go out to I'd love to go look at the sand on Huntington Beach, and I look in both directions, and that's not the complete, but if you went to all the beaches of the world, all the grains of sand that's in there, it's not as much as the number of stars that are in the universe. And the Bible stated this. This was at the time when people who looked up at the universe could only count about 1,000 to 3,000 stars with the naked eye. And actually they said that here's the Bible, here's an evidence that the Bible is wrong, because I can count that many. It's not as limitless as. And then later on, as we were discovering through the telescope, they said, yeah, that's what it was. They were right. So how was the universe formed? the Bible states that in the beginning God created the heaven and the earth. The things that are seen were not made of things which are visible. So these two statements are actually very similar to what current scientists say about that believe in the Big Bang, that the universe was formed. I saw this insert in yellow and I thought it was kind of funny because basically this guy condensed the Big Bang to saying, in the beginning there was nothing and then it exploded. So, I don't know. Poke fun at it. So the energy required to form the universe is infinite. I mean, I like, as I said, I like to crunch numbers, and people have estimated the mass of the universe. And I looked at, using Einstein theory of relativity, E equals mc squared. If you have a certain amount of mass and if you completely annihilate it, you get a certain amount of energy released from it. Like the atom bomb, about 0.1% of the hydrogen atoms that fuse into helium, 1/10 of the mass of the hydrogen atoms is the pure energy that is released in an atomic explosion. But you can convert that the other way, but we just don't know how to make mass out of energy, but we know how to get energy out of mass. So if you do that, you come up with a number which is like 10 to the 60th power tons of TNT. What does it mean? It's big.
Mm-hmm.
It's huge. So what caused the universe to form? And right now, I think scientists still don't know. They have models of how the universe was formed, but I think the fact that dark matter and dark energy have been discovered recently, and we still don't know what that is, it's hard to put your faith in a model that says, well, this is how it happened. And some of these predictions go back to the very few microseconds of the Big Bang. I have trouble with that because if 95% of the universe is not visible to us, then we're only working with 5%. I wrote models for fluid thermodynamic models, and if I would have told my boss that, look, I only have 5% of the effects simulated here, but that's all I can do, but it's really good. I think it would have thrown me out. But anyway, that's just me. The Bible declares that God created the universe, and it says that by the word of the Lord were the heavens made, and all the hosts of them by the breath of his mouth. The worlds were framed by the word of God. So God says, is there anything too hard for me? And so I stop and think about this. If God didn't have to take a break after he created the universe, take a nap and said, I got to recover from this. This was taxing. But for God to bring this universe into existence just by speaking it, it just shows the infinite power that he has to create compared to what we see. We're at awe of this. And it's also a lesson for me because God says, is there anything too hard for me? A lot of times I think that the situation that I have it's hard for God to solve my situation because it's so difficult, but not for God. God is infinite. There are no difficulties for him. So I'm going to jump into this because I didn't know where to put it, but this is talking about the Big Bang, the fine-tuned universe, and this is really, again, a recent discovery where they discovered that when the universe expanded from its original state, that there are a number of physical constants, like gravitational constants, speed of light, mass of electron, neutrons, hydrogen atoms, etc. There's a number of them. There's like 10 or 20 of these parameters, these constants. They realized that if these constants were off just a little bit, that the universe would not have formed the way it did. If it would have been off slightly, the universe would have either expanded and would have continued to expand such that no stars or galaxies were formed, or if they were smaller in a different direction, it would have collapsed back to itself. And this is a recognized fact right now, that the universe is fine-tuned to create stars, galaxies, and the world we live in. So there are obviously always theories of why this is. Okay? So scientists who don't accept divine creator, they had to come up with an explanation. So the explanation they came up, one of them, is that because these parameters are so fine-tuned that we just happen to be living in the universe where all this came together just right. Which means that there must be an infinite number of universes. It's called a multiverse. There are an infinite number of universes out there where you and I are sitting somewhere and having the same conversation because it would have repeated itself. So it didn't really answer the problem. It just pushed the problem a little bit further out of reach because now it made it even more difficult to explain, well, what caused the Big Bang? What caused the universe to form? The other one is, it's called top-down cosmology, and basically it says the universe's initial conditions consisted of many possible conditions that only a small fraction of which contributed to the conditions we see today. So I got this as a quote. I'm not sure I really understand what that means, but basically it says that there were other initial conditions that we're not aware of, but again, it doesn't explain what these initial conditions were and where did the energy to create the universe came from. And then, of course, my favorite is intelligent design. I believe that this is an evidence of God creating a universe that is so fine-tuned that it couldn't have happened just by itself. It explains both the designer and also the source of the energy. God is infinitely greater than our universe. King Solomon, when he was dedicating the temple in Jerusalem, he said, "Behold, the heaven of heavens cannot contain thee," meaning that this temple can't contain God. And it's true. Who is like unto the Lord our God, who dwells on high, who humbles himself to behold the things that are in heaven and in earth? You know, when we look at the universe, when we look at this enormous number of galaxies and stars, we look at it and we go, wow, that's huge, that's big. But from God's perspective, he looks at it and he humbles himself to behold what's on the earth. I mean, this is how amazingly great God is. I tried to put a chart together to define infinity. The symbol, this doesn't do much for me to say this is infinite. Mm-hmm. So I tried to say, okay, a visual thing. If I take on a scale, the subatomic particle, the galaxies in the middle, and the 14 billion light-year universe, even you can throw in the part that we don't see. All of this is finite because it wasn't there at one time, it's now there, so it's finite. So if I start to put this on a scale of infinity, what happens is on a scale of infinity, you can't differentiate the 14 billion light-year universe from a subatomic particle. Meaning infinity is so much greater, so much bigger than either one of these. And it takes a while for us to comprehend that infinity is extremely big. And I think this is how we should view God. We should view God not as mighty, almighty, all powerful, but all of that and even more than what we can imagine. He's far more powerful. He's far more greater than we are. He's truly infinite. So the next few charts, about 3 charts or so, I'm going to talk about the attributes of God in terms of infinity, because again, the heavens declare the glory of God, and we can see his invisible attributes through creation. So first of all, to define who the Creator is, the Bible says that Jesus created everything. It says that in Hebrews it said, "You, Lord, in the beginning laid the foundation of the earth, and the heavens are the work of your hands. In the beginning was the Word, and the Word was with God, and the Word was God. All things were made through him, and without him nothing was made that was made. Who is the image of the invisible God, for by him, Jesus, were all things created that are in heaven and that are in earth, visible and invisible, whether they be thrones or dominions or principalities or powers. All things were created by him and for him. And he's above all things, and by him all things consist. And it says, you are worthy, O Lord Jesus, to receive glory and honor and power, for you, Jesus, have created all things, and for your pleasure they are and were created. So, not thinking about attribute of infinite God, of infinite knowledge. David said, great is our Lord and of great power. His understanding is infinite. And I like what David wrote, because he, being out in the fields, he saw the universe, and he had a deep faith in God because he knew God was great. Because of his faith, he was able to overcome Goliath, kill the lion with a bare hand and a bear with his hand. And it reflected his faith. And I think our faith is, in a sense, linked to how we see God. If we see God as being infinite, our faith is going to be strong. If we see God as a mere human with limitations, then our faith is going to be weak. So our faith is dependent on how we view God. With infinite knowledge, God knew everything from the beginning. Whatever could be known was always known by God. And this is kind of comforting to me, for God knows everything about me. It says that before he formed me, he knew me. Before he formed you, he knew you. Before even the worlds were laid, the foundation of the world, he has chosen us. He knew us. He didn't come to know us as we accepted him, but he knew us even before the universe was created. And he knows us even after the universe is over. He knows what we're going to be like in eternity. He has this tremendous knowledge. So I don't have to hide anything from God, because he knows everything that I'm doing, I did, and I ever will do. There's nothing I can hide from him. He knows our thoughts. The Lord knows the thoughts of men. It says, you understand my thought afar off. There is not a word in my tongue, but behold, Lord, you know it altogether. So his knowledge is infinite. God's love is infinite. And I love the fact that David related God's love to the heavens. He says it's even higher than the heavens. For the greatest your love, it's higher than the heavens. I love that. I'm so glad for that. But how is infinite love manifested? How do we what is infinite love? And I was thinking, if a man lays his life down for his family, his children, that's great love. If a man lays his life down for his neighbor and friend, that's great love, but it's not infinite love. Even if a man lays his life down for his enemy, it's probably the greatest love that a human can express in this body, but that's still not infinite love. Infinite love can only be expressed by God, because what he did, he became man, became one of us, and he laid down his life. He emptied himself of his godhood, Jesus did, and laid down his life for us, who were his enemies, and died for us out of love. So Jesus, being in the form of God, took upon him the form of a servant and was made in the likeness of men, humbled himself and became obedient even to the death of the cross. This is the greatest love that could ever be expressed. There's nothing greater for an infinite God who created man, fallen man, sinful man, and to sacrifice himself so that he could redeem man. Infinite love cannot be earned. It is something that is given. There's nothing I can earn to get God's love, and there's nothing I can do to lose God's love. His love is eternal, is constant. And we know that John 3:16, for God so loved the world that he gave his only begotten Son, that whoever believes in him should not perish but have everlasting life. And then even more, in Jesus at the Last Supper said, praying to the Father, says, I in them and you in me, that they may be made perfect in one, and you have loved them as you have loved me. God's love for us is the same as his love for his Son, his only begotten Son. And that is, and when you think about that, us, this little grain of sand on a grain of sand, from God's perspective, that is infinite love. God's mercy. Again, it's interesting that David relates God's mercy to the heavens, where it says, "For as the heavens are high above the earth, so great is his mercy toward them that fear him. As far as the east is from the west, so far has he removed our transgressions from us." The mercy of the Lord is from everlasting to everlasting upon those who fear him. God, who is rich in mercy because of the great love with which he loved us, even when we were dead in trespasses, made us alive together with Christ. The Lord is merciful and gracious, slow to anger, and abounding in mercy. This is the nature of God. It says, "Who is a God like unto thee, that pardoneth iniquity? He retaineth not his anger forever, because God delights in mercy." I mean, that's incredible. God's grace is infinite. There's a difference between mercy and grace. Mercy is not getting what I deserve, while grace is getting what I don't deserve. So it'd be like if my children were misbehaving, instead of punishing them, I would take them to Disneyland. That would be grace. It would be getting something that they don't deserve. But this is God's infinite grace. He's so generous that he showers us with good things. God blessed us with every spiritual blessing in the heavenly places. This is not talking about forgiving us, but he's saying, this is what I'm putting you in. This is that your relationship will be with me. Blessed us with every spiritual blessing in the heavenly places in Christ, just as he chose us before him, before the foundation of the world, that we should be holy and without blame before him in love. God has chose us to be holy and without blame him even before the foundation of the world. This was God's plan for us to be with him. This is his grace. It's not just going back to the idyllic Garden of Eden, living with animals in a very idyllic scene. This is God is reaching down and says, here, you're going to be part of me, part of my Son. Having predestined us to adoption as sons by Jesus Christ to himself, according to the good pleasure of his will, to the praise of the glory of his grace, by which he made us accepted in the Beloved. For all have sinned and come short of the glory of God, being justified freely by his grace, through the redemption that is in Christ Jesus. God chose sinful men to make him into his image. Is there anything greater? Peter says, rest your hope fully upon the grace that is to be brought to you at the revelation of Jesus Christ. There is no greater grace. It is truly infinite. And I think, for God to demonstrate infinite grace, infinite love, infinite mercy, in a way, he had to deal with fallen humanity. If God would have elevated the angels to his rank, it wouldn't have been infinite. It would have been tremendously great, or his love wouldn't have been infinite. But to reach down and touch sinful, rebellious men who hated God, and to bring him into a relationship with him, that is infinite. So this is the future that awaits us, the glory that will be revealed in us. Jesus said at the Last Supper, he said, to pray to the Father, said, the glory which you gave me, I have given them. Earlier he prayed that the glory that I had with you before the foundation of the world, to give it back to me. And then he says, the glory which you gave me, I have given them to them, that they may be one, just as we are one. Who will transform our lowly body that it may be conformed to his glorious body. This is our future. This is God's infinite grace, to be conformed to the glorious body, to be like Christ. For whom he foreknew, he also predestined to be conformed to the image of his Son. Moreover, he predestined, these he also called. Whom he called, these he also justified. And whom he justified, these he also glorified. When Christ, who is our life, appears, then you also will appear with him in glory. Beloved, now we are children of God, and it has not yet been revealed what we shall be. But we know that when he is revealed, we shall be like him, for we shall see him as he is. The Spirit bears witness with our spirit that we are children of God, and if children, then heirs, heirs of God, and joint heirs with Christ, if we indeed suffer with him, that we may also be glorified together with him. So in ending, God's love is infinite. He loves us beyond our understanding. There's no reason we should be afraid to come before God. He knows every little detail. His knowledge is infinite. He knows everything about us. His mercy is infinite. There's no sin that I can do that he won't forgive. Jesus has paid the price for our sin. He said, it is finished. There's nothing I can add to his finished work except to receive it and to give him thanks. Jesus has brought us into a relationship with God that is superior with the angels. We are sons of God, heirs of God, joint heirs with Christ. There is nothing greater than what God has done through Jesus Christ. Nor is there salvation in any other, for there is no other name under heaven given among men by which we must be saved. So this is the end. I think the heavens truly declare the magnificence of God. God has demonstrated his divine nature in creation, and who he is just beyond our comprehension. I love to meditate on this. Occasionally I drift off during church service, and I just think about how great God is, and it's going to be an awesome time when we see him face to face. It's more than we can imagine. So with that, I'd like to thank you, and I thank you for your patience. I apologize for going so late, and we can. I'd like to pray just a quick prayer in closing, and then if anybody has any questions, if you want to do it from there or here, we can do it either way. Dear Heavenly Father, Lord, we thank you for this journey that we could see your work at hand, Lord, your creation, that the wisdom that you created. And Lord, there's no doubt that this is your work. It's not something that came about by accident. We thank you for opening our eyes, Lord, for giving us the faith to trust in you, for trusting and believing in the Lord Jesus. We thank you for what you have accomplished in this world, Lord, your love, your mercy, your grace, and the future that awaits us. And Lord, I pray that we would take this seriously and thank you and realize that there is no other name under heaven among men except yours, whereby we may be saved. And we thank you that we know him, and Lord, we thank you for this evening. Bless us according to your infinite love and grace. In Jesus' name we pray. Amen. Thank you. Okay, so if you have questions from there, yes, sir.
Yeah, I got one. My question would be, when you look up at the sun, it's so quiet, but what would the noise decibel be at the sun like? Is there don't you think it would be so loud? The noise. It's not quiet. When you look at it, it's quiet. When you get close to the sun, I'm sure the noise is so unbelievable loud, right?
Well, yes, in a certain respect, it's true. There is a noise on the surface of the sun. They can see the sun surface vibrate, and they have these things. But for us to hear it, sound is only traveled through a medium like air. Okay. And because there's vacuum there, the sound doesn't really travel. Now we have magnetic and plasma that's subjective, that comes up. But as far as audible sound is concerned, it's not there. As soon as you're outside of the atmosphere of the sun, there is no sound.
Okay, thank you.
Yes, sir.
You mentioned that our planet, our galaxy was traveling at, 400 and some million miles an hour. My question is, what do you use as a stationary point to measure that from?
Well, these are relative speeds. So they actually, can measure the motion of the galaxies. I don't know how they came up with this one. This may be the speed that the Andromeda galaxy is moving away from us, so it may be a relative speed. But they have these measurements. It's a quasar that they use as a type of quasar, which when it erupts, it gives out a certain amount of light energy, and it's a candle. And they can tell from that particular quasar and the intensity of light how far it is and how fast it's moving. And from the redshift, they can see the Doppler effect, that is, as you move towards the lower frequency of the electromagnetic spectrum, you can see the shift, and you can see based on that, you can deduct what the speed is. Some of these galaxies, they think are moving at relativistic velocities like 90% the speed of light. I mean, it's I mean, just to put that in perspective, I was curious. If you take a grain of sand and you accelerate it to 90% the speed of light, and it impacts the Earth, it's equivalent to like 5 tons of TNT. Just a grain of sand. I mean, that's how much energy you have to. Now you talk about 100 billion galaxies. I mean, 100 billion stars in our galaxies and billions of galaxies moving. That's why this dark energy is so interesting, because until now they thought the universe would eventually come back and collapse in itself. As a matter of fact, one of the things, when they first came up with the theory of the Big Bang theory, the astronomers were actually, they were at the time, but when they said that all this thing came from a single source and it blew up, the astronomers were against this. They didn't like this theory. They liked the uniformitarianism theory, which meant that everything was there just kind of floating around. Because the reason they didn't like this, because this was very close to what the Bible said, that it was created from nothing, and it had a beginning, and they fought against it. But then eventually they said, well, the evidence is there, we can't say. And then they were hoping that as the universe expanded, that the gravity would take over and pull it back, and the Big Bang would be followed by a big crunch. But then they discovered that things are actually accelerating and moving away faster and faster. So, so these speeds are amazing. Yes?
You even made the mention that it's infinitely small, like an atom, and infinitely large is our universe, and God is beyond time and space. So when we meet Jesus, we will see all this in perspective of what his purposes are. I don't grasp what the purpose is of all this infinitely, but except to see God is in everything, whether it's big or small.
Well, you know, I don't know, did we went over the one that the probability of having another Earth like us, you know, basically it says, you know, nothing.
Yeah.
Well, you know, it basically says that, and this is the question, are there other living things like us? And I don't think so. I think we're it. And because God doesn't have to justify the universe to say, well, okay, I made this big universe so huge, I got to put things over there, you know, I can't just leave it uninhabited. I think the whole purpose of the universe is for God to give us a tool, a teaching tool that says, do you want to know how big is? This is how big is, and I'm even bigger than this. So without that, you know, if we're just talking about the God living on the top of a mountain top or on a distant planet or distant galaxy, he would be too small. So I think the whole purpose of this universe is to proclaim the grandeur, the majesty of God. And when that lesson is over, time for a new lesson. You know? Yes, sir.
You kind of touched on it in one of your slides when you had like the asteroid belt. Do you have a theory on if that used to be a planet, and if so, what caused it to break up?
Well, and you know, that's kind of interesting. Whatever I say now, I probably would change it next time the question is asked, but I think the asteroid belt, it kind of contradicts, first of all, the idea that these planets were formed by collision, because there you have this asteroid belt with who knows how many little rocky planets floating around nicely. They're not coming together and forming into small, dwarf planets. I don't know. I think maybe this may be a speed bump again, just like Jupiter absorbs these incoming icy comets. I wonder if the asteroid belt may be another speed bump as stuff comes in from the outer solar system. It gets captured, and it's another level of protection. But I don't think it's a planet that was exploded. As a matter of fact, the more I see the planets, the order of them, this is not an accident. Something didn't just come through and blow it to smithereens. These are there by design. They're specific places. They have specific sizes for a very specific purpose. So that's what I think. Yes, sir.
What about the constellations that when we look at the sky, we see Orion, and we see the big and little bear things and so forth. But they don't seem to be changing at all. If they're moving away from us, why aren't they expanding away from us? Why is the Orion belt still the same all the time?
Well, I don't know. I'm not really not qualified to talk about astrology. I really don't know. But I think we're looking at a very short time in history where we've seen this. I mean, humanity is only, really, I believe it's only 6,000 years, as the Bible says. We haven't been around. And it's for us to, whatever God wanted to display in that in terms of a message. And obviously there's messages there because the wise men coming from the east looked at it and they were able to figure out that the Messiah was born in Jerusalem. So I have no idea what it is. I'm fascinated by it, but again, we're looking at a very small time in the history, and these stars that are nearby and some of the gas clouds are moving fast, but there's at such small distances that they don't seem to move perceptibly.
So what is your idea about what that big star was that the Persians became, saw and came?
I have no answer. I don't
You
know.
must have read about what Daniel wrote
Yes.
many years ago.
Yep.
And out of that, they figured out what it was.
They figured out. I don't know. It almost seems like it may have been a real star. Some people speculate it may have been a supernova that flared up. But then you have the story that the star stopped over the Bethlehem over. So I don't know. I have no answer. All right. Any other questions? Yes, ma'am.
We were at a debate recently between atheists and the Christian community, and there was an argument that water has been found on Mars. And I heard you say earlier that it has not. What do you think the atheist perspective?
Well, they're looking for evidence of, and of course there may be water, but when you think of it, it's not like liquid water like we have it. Because for one thing, in order for you to have water in the liquid phase, you have to have pressure. The reason we have liquid water because we have one atmosphere keeping that water in the liquid phase. Plus the temperature is here to keep it in the liquid phase. If you take that water from here and go into orbit, and we did an experiment that on the space shuttle, that when you open that liquid to vacuum, it flashes and becomes ice crystals, and then just flies apart. There is no liquid water at zero atmosphere. The pressure on the surface of Mars is 0 atmosphere. It has an atmosphere, but it's basically 0. So then they say that, well, there may be water underground. Well, I don't know. Okay. If you want to believe that, fine. But, and it doesn't matter. I mean, there may have been things that impacted, and there's a polar cap, and there may be some water, but it's definitely not like water we have on the Earth. It's this moisture and water ice crystals maybe under the thing, but I wouldn't bet. See, one of the things that I love space exploration because I grew up in it, and it was exciting to discover things. And I was all for it. But now I've kind of, maybe I'm getting old, I'm getting to be an old man, but now when we talk about going to Mars, it's not like, they make it sound like, Doctor, when the pilgrims came from England to America, they crossed the ocean, they pioneered, they landed. This is not that, going to Mars, there's nothing there, There's absolutely nothing. You can't, I feel sorry for these people if they ever go to Mars, they're dead. Because it's not only the radiation from the sun, if it comes that way, they're toast. There's no way to protect them. But also, they can't come out of these shelters. They can't go and do farming. In order to use photosynthesis, you have to have all this stuff that we have here. Plants, the microorganisms, and all these things have to be there. And I think this is, I don't know what to say, what to call it, but I think it's really foolish to send men there right now. I mean, if you send them there and bring them back, fine, okay, it's expensive, been there, done that. But to actually think that you're going to build a colony and colonize it, they're missing a big part of the picture, I think.
The Indians will help them.
I hope there are some underground, But no, it's fascinating then to see the universe, and I love. And I was telling you about an experiment that we did in space. And the space shuttle, when it went up into orbit, it had all this liquid hydrogen and oxygen left in its lines after it separated from the external tank, and they didn't know how to get rid of it, and so we said, well, just open it up and let it go to space. So we had one line that had hydrogen and the other one had oxygen. And unfortunately, these lines were right above the wing of the orbiter. So we knew what would happen, that when this gas came out in the solid, it would impinge on the wing. But the astronauts opened these valves so fast that the plume impingement on the oxygen side was much greater than on the hydrogen side, so that the orbiter actually started rotating. The thrusters were trying to correct. And Senator Garr was on that flight. This was his maiden flight. And they got spooked because once you start spinning something up in space, it's very hard to unspin it. And it was out of control. So I worked on it. When they came down, they banged on the table and says, "You didn't tell us about this." We told them about it. You guys did it much better than we thought you could do it. So. But anyway, well, thank you so much. I think we got all the questions. If you have any other comment, I would love to talk to you. As you can tell, this is my adrenaline for today. And so, thank you.